By 2035, a new kind of machine could help design drugs before diseases spread, balance power grids before they collapse, discover materials before shortages hit, and solve problems so complex, today's supercomputers basically tap out. It's called quantum AI, and if it works the way researchers think it will, the next decade won't feel like an upgrade. It'll feel like a rewriting. One quick correction. Some people say by 2025, but 2025 is already behind us. The real roadmap points to 2035. And in this video, I'm going to show you the 5 breakthroughs that, combined, could redefine medicine, energy, finance, and climate science. But first, you have to understand why this isn't AI plus faster computers. It's AI plus a different set of rules. AI is already powerful because it learns patterns from massive data. But there's a ceiling. Some problems explode in complexity so fast that even the best classical machines get buried. Quantum computers don't just do the same thing faster. They approach certain problems differently. And here's the twist the report emphasizes. The near future isn't pure quantum. It's hybrid, classical AI steering quantum processors like specialized engines. So, imagine a Formula One car. Classical computing is the chassis. AI is the driver. Quantum? That's the experimental turbo that can change the race, if it doesn't blow up. And yes, today it still blows up sometimes. Noise and decoherence are real constraints. So the question is, what changes when it stops blowing up? The report lays out 5 breakthroughs that stack on top of each other. 1. Hybrid quantum AI algorithms. 2. Scalable hardware, logical qubits. 3. Drug discovery acceleration. 4. Optimization of real-world systems. 5. Climate plus scientific discovery supercharged. Miss one, and the future slows down. Hit all 5, and the future speeds up. Let's start with the one that arrives first. This is how quantum AI wins before we have perfect quantum machines. The report highlights hybrid approaches, variational algorithms, where a classical computer trains a quantum circuit like it's tuning a model. Translation? We use AI to squeeze useful signal out of noisy quantum hardware right now and improve year by year. This is the bridge from cool demo to commercial results. But this only works if the hardware grows up, which leads to breakthrough 2. This is the part almost everyone misunderstands. When you hear 1,000 qubits, don't get hypnotized. The report's real focus is logical qubits, error-corrected qubits stable enough to run deep, meaningful algorithms. Because raw qubits are like raw recruits. Logical qubits are trained soldiers. Here's the roadmap the report describes. 2025 to 2028. 1,000 to 5,000 qubit systems. Greater than 99.5% 2-qubit gate fidelity. Early logical qubit progress plus wider cloud access. 2029 to 2032. Fault tolerance gets real. 50 to 200 logical qubits supported by thousands to tens of thousands of physical qubits. 2033 to 2035. Hundreds to thousands of logical qubits. Quantum integrated into heterogeneous data centers with classical HPC. And when you hit that last stage, you unlock the next breakthrough, one that hits you in the pharmacy aisle. Chemistry is quantum, and simulating molecules is one of the hardest things classical computers try to do. Which is why the report argues quantum AI could drive 30 to 50% reductions in pharma R&D costs by accelerating the search for compounds and improving prediction of molecular behavior. And it maps early stepping stones, near-term pilots in quantum chemistry for molecules around 20 to 30 atoms, then scaling as hardware matures. Here's the dramatic implication. Instead of testing 10,000 bad ideas to find one good one, you test the right 100 first. Not because we got lucky, because we simulated reality closer to how nature actually works. But medicine is only one battlefield. The next one is everywhere. Optimization is the invisible algorithm behind modern civilization. Routes, schedules, energy, risk, supply chains, pricing. The report forecasts quantum optimization becoming increasingly routine for critical infrastructure, especially in the 2033 to 2035 window. And it highlights energy impact, 25 to 30% grid efficiency gains as a plausible range, if better forecasting and optimization are deployed at scale. That's not a tech improvement, that's a geopolitical lever. But the biggest shock might be what happens in science itself. Because quantum AI doesn't just optimize the world, it accelerates discovery. The report doesn't claim quantum AI magically fixes climate change. It says quantum AI could help through 1. Better climate prediction, 2. New clean energy materials, 3. Optimized energy systems. And then it drops a huge claim. Materials discovery timelines could improve by 10 to 100 times by 2035. Imagine inventing a better battery chemistry not in decades, but in a fraction of that time, because you can simulate and search chemical space far more effectively. That's why this matters. But if this is the power, what's the price? Because every leap comes with shadows. The report flags major risks. First, today's quantum hardware is still fragile. Noise and decoherence remain real limits. Second, a quantum divide where only a few companies or countries control the most powerful systems. Third, security. Long-term, quantum threatens RSA/ECC cryptography, pushing a transition to quantum-safe cryptography. And then there's governance, privacy, bias, explainability, especially in medicine and infrastructure. So the future isn't only about what we can build, it's about who gets access and who gets protected. Here's the chain reaction. Hybrid algorithms extract value early. Hardware evolves from qubits to logical qubits at scale. Drug discovery accelerates. Optimization reshapes infrastructure. And scientific discovery, materials, energy, climate, gets a new gear. By 2035, the report argues, the market could exceed $100 billion because these breakthroughs don't add up. They multiply. If you want part 2, I'll break down the timeline signals to watch, the specific milestones that tell you whether this future is arriving or stalling. Because when AI meets quantum, the question isn't, will life change? It's who adapts first.